In this video, I want to have a look at the interior and exterior angles of polygons. So we'll start off looking at the most basic polygon, which is a triangle. So the interior angle sum of a triangle is 180 degrees. So the three angles inside all have to add up to 180. So let's have a look at an example. If we've got a triangle, we've got an angle of 110 degrees, 50 degrees, and theta. And we want to find out what that theta is. Then we'd write theta is 180 degrees minus 110 degrees minus 50 degrees. And then we'd put our reason in, which is angle sum of a triangle. And then we'd figure that out. So 180 minus 110 would be 70, and then minus 50 would leave us with 20 degrees. So you have to have that reason in there. All right, next I want to look at the exterior angle of a triangle. So what the exterior angle is if we have a triangle and we extend one side of that triangle out, then this here is the exterior angle of that triangle. So what this says is the exterior angle is equal to the sum of the two opposite interior angles. So if we call this angle here theta, then that angle there would be equal to the sum of these two angles inside. If we call them alpha and beta, we would have theta is equal to alpha plus beta. So not the one that's next to it, not the adjacent angle, the two other interior angles. So let's have a look at an example. So if we've got here 50 degrees and 60 degrees, and we've got theta here, then we would write theta is equal to 50 degrees plus 60 degrees, and then we need to put a reason, so exterior angle of a triangle, and then 50 plus 60 is 110 degrees. So that's one type of question you might get. The second type of question you might get might give you the exterior angle and ask you to find one of the interior angles. So if we had a question that looked something like this, so we're told that this is, say, 120 degrees. We know that this one here is 70, and we're asked to find this angle here. So then we'd have that theta would have to be 120 degrees minus 70 degrees, because we know that these two added together give us that 120. Again, we've got to have that reason in there. And then 120 minus 70 would give us 50 degrees for that interior angle there. All right, so that's triangles. Next, I wanted to have a look at quadrilaterals. So any four-sided shape. And it says that angles, interior angles, add up to 360 degrees. So pretending all those lines are straight, we're saying that all four of those angles add up to 360 degrees. Now the way you can see that is you could split this shape into two triangles, so drawing from one corner to the other. So if we draw a line down here, we could have gone the other direction as well, it doesn't matter. But now we have two triangles, and we know that the interior angle sum of this triangle is 180, and the interior angle sum of this triangle is 180. So that means altogether, all four angles in that quadrilateral add up to 360 degrees. So let's have a look at an example. Okay, so here we've got a quadrilateral. It's got angles 100, 120, 80, and theta, and we want to find theta. So we're going to write theta is equal to 360 degrees minus 100 degrees minus 120 minus 80, and we'll write in our reason that it's the angle sum of a quadrilateral. And then working all of that out, we'd have that that angle there was equal to 60 degrees. So now we want to extend that. So we've got the interior angle sum of triangles and quadrilaterals. We want to extend that to any polygons with any number of sides. So I've got three different polygons drawn here, and I want to have a look at how we can figure out the interior angle sum. So first off, this shape here has 5 sides, this one has 6, and this one has 8 sides. Now what we did with the quadrilateral to figure out its interior angle sum is we broke it down into different triangles. So we're going to do the same thing with these shapes. So you're going to pick any corner to start in, and you're going to draw in all the diagonals for that shape. So in this one, we'd have a line coming down here and a line coming down here. So that's broken that up into 3 triangles. In this one, again, you can pick any corner to start with. I'm going to draw in all the diagonals. So in this one, it's broken that down into 4 triangles. Then in our last shape here, so drawing it into all the other corners. Okay, so that's broken down into 1, 2, 3, 4, 5, 6 triangles there. So if you have a look at the relationship between the number of sides and the number of triangles the shape gets broken into, hopefully you can see that the number of triangles is always 2 less than the number of sides. So if we wanted to figure out the interior angle sum of this one, we'd go 3 times 180, because there's 3 triangles and each triangle is 180. For this one, we'd go 4 times 180, and this last one would have 6 times 180. So making that more general, if we have a polygon with n sides, to figure out its interior angle sum, we would write n minus 2. That'll tell us how many triangles that shape can be broken down into. And then whatever that answer is, we'll times that by 180 degrees. So that there is the formula that you need to remember to figure out the interior angle sum of any polygon. So the first example we want to have a look at here asks us to find the interior angle sum of a 10-sided polygon. So to do that, we're going to substitute that into our formula. So our formula is n minus 2 times 180. So in this one, our n is 10. So we'd go 10 minus 2 times 180, which will give us 8 times 180, which is 1,440 degrees. So all the interior angles in that 10-sided polygon add up to 1,440 degrees. Our next question asks us to find the size of each interior angle in a regular pentagon. So this time we don't want to know the angle sum, the total angle sum. We want to know how big each angle is. Now, the fact that it's a regular pentagon means that every angle inside that pentagon is equal. So they're all the same size. So what we're going to do, we're going to start off by finding out the interior angle sum and then divide it by the number of angles there are. So because it's a pentagon, that's a 5-sided shape. So we're going to have 5 minus 2 times 180. That would give us our interior angle sum. And then we're going to divide that by 5 to find out how much each angle is. And if we do that, we'll end up with 108 degrees. The last thing we want to have a look at is the exterior angle sum of any polygon is going to be 360 degrees. So that means that all of these exterior angles in this polygon, for example, have to add up to 360 degrees. So if we want to find the size of that angle theta, we'd have to go 360 degrees and then subtract all of the angles that we know. So minus 74 degrees, minus 90 degrees, minus 80, and minus 85. And our reasoning there is exterior angle sum. So doing all of that, we'd end up with 31 degrees. Our last example asks us to find the size of each exterior angle of a regular octagon. So again, regular means that all the sides are equal in length and all the angles are equal in size. So because it's an octagon, it's going to have 8 angles. We know that all 8 of them together add up to that 360. So to find the size of each exterior angle, we'd go 360 divided by 8, which would give us 45 degrees. And again, we should have in there exterior angle sum as our reason. Okay, so that's an overview of all the angles, interior and exterior, to do with polygons.